Hi all, a very good morning.
Hi, good morning.
I hope you guys are able to see my screen and hear me.
Yeah,
Let me just give me a minute. We'll quickly make a start here. So before we make a quick start on what is cloud computing and what is the AWS and other things, just to keep it a little simple here. So if you have any queries at any point of time, please feel free to open up your mic and talk, or if not, you can also post a message in the chat box and you can ask me a query. So don't hesitate to ask any of the queries in case if you have at any point of time. So we'll surely ensure to take care about all the queries that we have. So you have both the channels open up. One is directly open up mic and you can talk, and another one is to put your query in the chat box. But don't hesitate to do so, because we are all here to learn about something new, and we may not be up to the mark. So as we come to learn, it's okay to ask any of the queries. So do not hesitate or feel that I may get offended or what would other people think about my silly questions or other things. It's all about learning. No one is perfect in this world, so we are all attending to be one of them. So making to a quick start here, we are going to talk about what is cloud computing first, what are the different types of cloud models, and then we are also going to talk about the journey of AWS and the course content that we are going to go through. Before that, myself Pawan here, and I have been in the IT industry for more than 12.5 years. I have trained more than 200 to 300 plus people across the different spaces in the world, helping the people to get matured with AWS and the cloud content. Just give me a minute. So I've trained almost more than 300 people across the different places of the world, on the cloud and the AWS maturity models. And I currently work as AWS and DevOps cloud architect, where I'm migrating the applications from the on-prem to cloud. So I also work with other clouds like Azure and GCP as well, but AWS still stands out far apart when we talk about how the services are pre-built, and we'll see through as in a part of our demo. So at any point of time, if you feel you are not able to hear, or if there's any glitch in the video feed or the audio feed, please feel free to let me know so that we can correct it. I hope all things look good until now. Great. So talking about the very first part, as I just said, we'll first look at what is cloud computing. So let's understand that we do not have any background of what is cloud or what is cloud computing all about. And we do hear a lot of buzzword these days in most of the companies that are talking about going digital or starting their services on the cloud. So what is cloud computing all about? So cloud computing, basically, if we look at a book-based definition, it says it's an on-demand delivery of IT resources and applications via internet with pay-as-you-go pricing. Now, the very first time someone would have told this book-based definition, it will surely be a lot of clumsy to help your mind grasp it, right? So it's something like this. As we see, these many services are available, and our mind may not be able to understand what is this all at a one single shot. Let's try to simplify this definition. So as we see, this particular slide would talk about or help us simplify what cloud computing is all about. So on the right hand side of my diagram here, I have a power center, which is basically helping in to generate power. And on the left hand side, if you see, I have an electrical meter fit across, which is going to measure the amount of power which is being delivered. Now, to understand this example much more simplified, in a real time of our day-to-day life, right? So we all have a home where we live across, right? And at each household, we have an electric meter which is also fit across, and at the end of each month we get an electric bill depending upon whatever services we have used across. It could be in terms of playing a music system, or maybe using a washing machine, maybe using an iron box, maybe using a TV, refrigerator, geyser, or other things. So at my home or household, I do have a lot of different things which I can actually use across. And based upon the usage of those components or the equipments, at the end of each month, I'm actually getting a bill. But if you notice one important share thing here, the power is actually getting delivered to your place all 24/7. It's just that when you want to utilize it, you switch on the plug and you are able to get started with using the particular equipment or a service, right? So electricity is available all 24/7 at your place. All you have to do is just go ahead and switch it on, and you will be able to make use of it. And whatever service or whatever equipment you are going to make use of, you are going to be charged accordingly. So each equipment will have a different rating. Specifically, the iron box and the geysers would be heavily utilizing the power, as well as the AC. TV, music systems, refrigerator, they are all minimal waste, right? So likewise, we have a lot of different equipments like tube light, fan, and other things at our home. So in this case, the power gets generated in this particular power center, and it is getting delivered with the help of electrical wires to our household. And at our household, we have different equipments which we are trying to use at any point of time as per our requirement. And as and when we use a specific equipment, it is getting recorded in this particular meter, and at the end of each month this meter is going to let us know how much I have to pay back to the power center. Similarly, instead of power center, when we talk about the cloud computing, we have something called as data centers. Now these data centers are actually managed by the companies like Amazon, Microsoft, or Google, DigitalOcean, IBM, you name it. There are a lot of companies across in the world, but top three at this point in the world are Microsoft, Google, and Amazon. So what do? They are actually managing these data centers. And how are we going to connect to the data centers? We are going to connect over the internet. It's a wireless, right? So if you see here in this case, connecting to power center, we are using the electrical wires, but connecting to a data center, we are going wireless with the help of the using the internet. Similarly, at home, we are trying to use different resource equipments like iron box, geyser, TV, fridge, washing machine. In the data center, we'll be able to use something like virtual machine, databases, storage, networking, and a lot of other components, right? So today we can understand that Amazon Cloud itself has more than 3,000 plus services across the cloud to offer it, right? So we can use all the different types of services. It could be in terms of Amazon Alexa, or it could be in terms of translate, it could be in terms of notifications, it could be in terms of messaging. So you name it, and there are the kinds of different services which are available. So as and when whichever service you want to use, you will be billed accordingly. So whenever you create an account on the AWS, this is account meter as you get through, and whatever services you are going to make use of, you are going to get billed accordingly, right? So if I'm going to use a virtual machine of specific size for a 10 hours in a month, I'm going to pay for that 10 hours. So we are going to pay as we use the specific set of services. Now going back to the definition to understand again, so what does it say? Cloud computing is on-demand delivery. When I say on-demand delivery, it means it is available all 24/7. It's up to us when you want to utilize it. So if you say I want to immediately start a virtual machine to process some data, yes, you can go through and get started onto it. And if you say you want to get started with the storage space, yes, you can surely get through. So it's on demand. The moment you go ahead and log into a cloud account and say I want to use storage, or maybe I want to use database, I want to create a virtual machine, I want to create a networking, I want to use messaging services, everything is available. It's just that when you require it, just go ahead and get started and use it. So here what we are getting, on-demand delivery of what? IT resources and applications. So IT resources are nothing but virtual machine, databases, compute, messaging, all these are IT resources and applications. So how are we going to connect? Via internet. And how are we going to pay? Pay as you go pricing. So whatever I'm going to use, I'm going to pay accordingly on the basis of that. So now if anyone asks you about what is cloud computing all about, it's very simple. It's on-demand delivery of IT resources and applications via internet with pay-as-you-go pricing. So always remember this electrical analogy, which will actually help you to understand the cloud services in a much better way. Like a power center, we have a data center. We use electrical wires to transmit the electricity. Here we are going to connect over the internet, and here we have household equipments. There we have IT resources and applications. Here we have an electrical meter which is going to measure the amount of services that we have used. There we are going to make use of a specific AWS account which is going to measure the number of IT resources we have used all across. That was about the cloud computing. So any questions, queries or doubts from any one of you until here? Or if you think I'm going a little fast, you can let me know so that we'll slow down the pace and will be easier for you guys. Great. So the next part we are going to talk is about what are the different types of cloud models which are actually available, right? So there are three major things to make a note of. One is public cloud, second is a private cloud, and third is a hybrid cloud. Now let's try to understand the difference between all three of them. So if you look at this specific diagram here, private cloud basically talks about completely private, right? Which means no one else has any access from the outside world, if you see. And if you talk about the public cloud, there are a lot of holes or the loops from which you can actually enter within. So if you see here, a lot of people will have access. So you can create an account on public cloud. I can create an account on public cloud. Someone else can actually create an account on public cloud, and we can actually start moving through, right? So everyone can create their own space within this public clouds. So AWS, GCP, Microsoft, DigitalOcean, they're all basically public clouds. And what is a hybrid cloud? Hybrid cloud is basically a combination of the public and the private clouds in this particular case. Now, if you look at it, this diagram pretty depicts how public and private clouds are merged together. To understand this, let's take one small example why this hybrid cloud comes into the picture. Now, surely, until now, a lot of IT companies have been trying to have their own private or the internal data centers, right? And now they feel that they should move on to the public cloud for a lot of better reasons. So we'll talk about the advantages of public cloud in few of our upcoming slides. So at this point, just understand that companies want to migrate their data from private clouds to public clouds for a maybe better cost optimization or better usage of resources and other things. So what happens in the private or the internal cloud in this case? I'll take a very small example in this part. Just give me a second and open up the slide. Yeah. So here, as you see, this is basically my company premises in which employees are working as well. We also have a data center within the company itself. Now, if you see, the company is of 3 floors, but maybe half of the floor on the top may be dedicated only for creating a data center within this company itself, which will be used by it. So if it's a single place at which my company resides, then having a data center within will also make sense, because all the people who are working in the company will actually connect to the same data center which is within the same building. But if I start expanding as a company, right? So if I have one branch in Bangalore, one in Hyderabad, one in Delhi, one in Mumbai, then having a data center in Bangalore, there will be a latency issues. People will have to look with the internet. So if there is any power problem at my office premises, then they'll not be able to even connect as well, right? So there's a huge need for the public clouds in this space. Now company starts transforming or migrating their applications to public cloud. So we understand that big companies have so many applications that they cannot transform it within a one day or so. It takes almost years together, right? So easily 2 to 3 years is what a migration timeline is given for the bigger companies, so that they can transform the huge amount of data whatever they're having in the on-prem to public clouds. So during that phase, so we may still want to have some connectivity between some of the applications which are already hosted on the public clouds with some of the applications which are already in the on-prem. So it could happen that I am transforming my web layer, but my database is still inside the private or the internal clouds, right? So I need a connectivity between my web application and the database, or maybe this application is dependent upon some other application which is still in the private or the internal cloud. So during those cases, I would require this connectivity to be established, and that is called as hybrid connection. Hybrid connection also means that you are trying to connect your public cloud with another public cloud. So as I just said, in my company, we use all three clouds, that is GCP, Azure, and AWS. So it does happen that we may want to transform some data from AWS to GCP, or from GCP to Azure, or from Azure to AWS. So in those cases, we need to have a hybrid setup, which means we are trying to collaborate on-prem with the cloud, or a public cloud with another public cloud as well. So this is all called as a hybrid cloud setup. Next is about understanding IaaS, PaaS, and the SaaS. So these are the different models within the cloud. Now, how are the services classified within a cloud? So before we go there, any questions or doubts until here? Yeah, we do have open source community clouds as well, which means there are some companies which actually help you to implement the cloud on a data center, which means you will get a portal same like the way you are using AWS, or the way you are using the Azure, or the way you are using the Google Cloud. So for your data center, they'll customize the complete UI interface, and within the background, they'll set up the networking cables, all of them in such a way that you will feel that you're actually connecting to a cloud itself. Yes, this is one of the first introduction class, Shekhar. Hope that answers, Yashi, for you. Yeah, so we'll talk about the advantages of cloud, Ankit, in the next couple of minutes, which will actually help you to understand it in more better way for why we look at cloud as a solution, why we cannot we run everything on a data center. So we'll come to that point, and that should answer your question. Yeah. So the next important part is about understanding IaaS, PaaS, and the SaaS. So before we go ahead and start understanding what is IaaS, PaaS, and SaaS, first let's understand the full forms, and then we'll come to that. So IaaS basically stands for infrastructure as a service. PaaS basically stands for platform as a service. SaaS basically stands for software as a service. So hugely, all the software components across the world are classified into these three categories, whether it is IaaS or a PaaS offering or a SaaS offering. We'll take you through examples of what is IaaS, PaaS, and SaaS in next couple of minutes. But before that, let's have a quick look at how the traditional IT can be compared with these three offerings from the cloud providers: infrastructure as a service, platform as a service, and software as a service. To understand this example, we'll have to rewind our life maybe 15 years back when the cloud didn't exist. So how did the software companies like IBM, TCS, Infosys, all these actually used to exist, and what was the kind of work they used to do in the last moments of time, and how they are doing it now? So we'll understand both of the phases. So let's rewind our life 15 years back, and we will see how the traditional IT companies actually worked across. To understand this, I'll take one small example. Just let me open up one of the picture here. So here I'm going to talk about this small picture where we see XYZ company on the left hand side and the ABC company on the right hand side. So what does these companies are talking about? So XYZ is basically a company which is actually known for manufacturing the automobile spare parts across the world. So it's basically a company which manufactures automobile spare parts, and they currently have an offline market across the world, and they have different distribution centers. Now they decide that we are so famous company, why don't we start our business going online, where people can directly order the equipments or the components which are required for their automobiles, and immediately we will start delivering it depending upon the places where we operate from, right? So in the first list of A1 countries, they may want to go online and set up their business for this automobile spare parts. So what they do, they actually go to ABC, which is a software company, to help them establish their online platform. So now they want to build a complete e-commerce platform from a scratch, which will help them to start their new online channel. So they go to the ABC software company. Now ABC software company has got some technical architects who will work out with XYZ company to understand what exactly is their requirement. So they first understand the entire requirement phase. So they say that we want to set up an e-commerce platform where we'll try to put across all the different automobile products, and we want to also ensure that we have a payment gateway in place so that people can pay directly via their credit card, and once the payment is received, we'll start the packaging and then we'll start the dispatching of the product. So there is a whole life cycle they want to put across as a online channel. So ABC company reviews the entire requirement and then they say that okay, we'll get started with it, but for that all of those things we will require some components. As I said, we are rewinding our life 15 years back, right? So how the data centers used to traditionally work at that point of time. So ABC company usually doesn't have so much of infrastructure to start for the XYZ company. So they will say that we will require a database where we can store all the transactions that are going to happen on online platform. We require storage because your automobile spare parts, maybe many of them, and each automobile spare part will have to take at least 5 to 6 images, right? So if you see through Flipkart and if you go to any of the product, you can see there are 4 to 5 images of each product so that it will give you a fair understanding of how the product looks like. So here again, for each and every automobile spare part, we'll also need to have 4 to 5 images from a different angles and the per view. So we need to store all those images. So we require a storage as well. Then we require virtual machines so that we can run the entire website, which will be serving the end users. And we require a networking component so that we can create a small network with database storage and the virtual machines. So this network can be accessed only by this company and ABC developers, and for the outside world it is only open up as a website. So that would be the networking model that we would like to put across. So as I just said, since we are going to rewind our life 15 years back, the ABC company may not have all of these components, or even if they have, they do not have the bigger in size, right? So what they do, so they'll say that this is what your requirement will suffice with, and in order to get started, we will have to first purchase the equipments, which will be costing around $1,000, because we want to start with a small to develop a prototype. So we'll take some set of machines, some set of networking components like routers, switches, and the storage boxes like hard disks. And for the database, we may have to purchase a license from Oracle or the Microsoft SQL servers, right? So all of these things happen in the background. So for that, initially we may require $1,000 to purchase the equipments and the software costs. And then the ABC company will have the developers who will start building the software. So for that, again, they'll charge a next amount that will be maybe, let's say, $2,500 to build the software. And once the software is built, surely the no software would within the first single shot will be a full bulletproof. So what we'll do, we'll have to maintain that software because we may get some issues. So payment gateway fails. So what happens now? Who is responsible? So bank has to give back the payment, or the XYZ company's online platform has to first find out whether the transaction was really unsuccessful and other things, right? So we really need a support team, or we also need to ensure that our software, we are going to maintain it in a very well way so that we can find out what are the failed transactions, where is the error coming out, how to fix those issues and other things. So again, for maintenance and enhancing the software, we'll have to charge $1,000. But if you see in this entire cycle, my developers didn't start the work until there was a sign off between XYZ and the ABC company, until we purchase the equipments. Once the equipments were purchased, again we need an administrator who needs to set this up. So it will easily take 3 to 6 months of time, in which we get a sign off, in which we go ahead and purchase the equipments, and then we set up all those equipments in a specific place, right? As I just said, we are rewinding our life 15 years back, so we will have to set up these equipments in maybe XYZ's data center, or maybe in the ABC software company's data center itself. So we'll have to set it up somewhere, and then my developers will be able to start the work. So we can see that it usually takes minimum 3 to 6 months of time where it is actually going to help the XYZ company to get started with. So how can we reduce the time to market? Or before that, now let's go back to understand the difference between the IaaS, PaaS, SaaS, and the traditional IT. So if you see here on the left hand side, which is a traditional IT, we have a lot of different components. Starting from bottom, if you see, one of them is networking, storage, servers, virtualization, operating system, middleware, runtime, data, and applications. So if I talk about starting the development work in this case, right, the first thing I require is networking to be set up, right? So I need to have a separate networking environment within which only the developers of ABC and XYZ company will be able to access this platform. Apart from that, for outside world, it's only exposed to HTTP and HTTPS protocols because it's a website. And inside the networking, I need to set up components like servers and the storage, right? And on top of it, I'll start installing the operating systems. But to create operating system, what we do, we are creating a virtualization layer. So with the help of virtualization layer, the good thing is just with just one single click, you can say whether you want a Windows operating system or whether you want a Linux based operating system. In Linux also, which is that RHEL or a Ubuntu or a SUSE Linux or Sun Solaris, whichever you want, with just one single click, you will be able to get it through. So virtualization layer, once we set up across our servers, it will help us to easily create any of the operating system that we want to get started with. And once the operating system is in place, now my developers can actually start building the application. They can start adding the data, and then finally, if the things succeed, we are going to run the application as well. So in case if we require a middleware or application layer, we'll also put it between. If not, that might not be required. So the traditional IT company, we just saw how the flow goes like, right? So first the XYZ company approaches the ABC company. ABC company will send the architects. They'll finalize the requirement. Once the requirement is finalized, then what they do, they'll go ahead and purchase the equipment. So this purchasing of equipment to the markets will actually take a lot of time. The reason being because some companies are very good in building servers like IBM and HP. Some companies are very good at storage like Seagate, Western Digital, Kingston, and all those things. Some companies may be good at databases like MS SQL and Oracle. So we have to involve multiple vendors to purchase the equipments, and each vendor may take different amount of time to deliver these products. And until then, my developers in the ABC company will be sitting free doing nothing at this point, right? So how can we actually ensure that things can be much more smoother? That's where we look at a cloud as a solution. So in the cloud, the first important thing if you see is infrastructure as a service. So here, if you are a technical architect who understands that I know what server to be used, I know how to configure a database, I know what networking environment has to be preset and how can it be developed, then infrastructure as a service is actually a solution for your question. So in this case, you can see I don't have to manage networking, I don't have to manage the storage, neither the servers, neither the virtualization, nor the operating system. As a technical architect, once the ABC company and XYZ company are in sync saying that we are ready to develop a software, I don't have to go and wait for the purchase of equipment. Straight away on the cloud, I can get started saying that, okay, let's develop a prototype on a Windows server or maybe on a Linux server. I'll tell my developers and immediately they get started. So you can see here 3 to 6 months of time, which usually takes for us to purchase licenses, softwares, and set up the entire theme is all reduced. So immediately I can get started with a very small machine and then ask my developer to build the application, store some sample data, run it across and show it as a prototype. And if that prototype goes success, then I can build it on a large scale. So here in this case, even if the prototype fails, I just pay for the amount of services that I have used for maybe a couple of weeks together, right? So at least I'm sure here that even if I fail, I'm just going to pay that small amount. But in this case, if I fail after 6 months or 1 year of after 1 year, if I fail across in the delivery of my project, then the entire project will be scrapped. There's a huge loss of money, huge loss of resources, and the other things. So with the cloud, time to market is going to get less. My developers are much more efficient. My teams are much more efficient in working as well. So that is from the infrastructure as a service point of view. So if you are a technical architect who understands what is operating system, what is a database, what is a networking environment should look like, then infrastructure as a service is a good solution. Let's say you are just a developer and you get a small client who will ask you to develop a website and get started for him, right? So now you don't understand all of these things. What is the operating system? What is a middleware? How does it integrate and other things? So for you, platform as a service is really good through. For a small scale or a medium scale businesses, platform as a service is a icing on the cake, right? So they can just ask a developer to start building application maybe on Python or maybe on Java, and then just start storing the data for it, and you will be immediately able to start application, because you don't manage any of these things, neither the servers, nor the storage, nor networking, nor virtualization, nor operating system, nor middleware, nor the runtime. We are not managing any of these things. So as a platform as a service solutioning, you manage only the application on which it is built, whether it's a Java, whether it's a Python, whether it's a Go, whether it's a Node.js, or whether it's any of the other languages. And you just start pouring your data within the application, and it will help you further. And next is SaaS. SaaS is basically software as a service. Now, software as a service is something which we all of them have used, in which means we don't have to manage anything. As an end user, I'm just worried about what software I'm getting, whether it is really useful for me or not. Best example is Gmail. So we are least bothered how the Gmail is actually built, whether it's built on Java, whether it's built on Erlang, whether it's built on Go language. No, we are not sure about it. And where is it hosted? What does it do? We are not worried about it. So as an end user, I'm just
Hello.
worried that sorry.
Yeah, Pavan, sorry to disturb you.
Yeah.
In this case, what is the runtime here? Because
So
in
software,
infrastructure as a service, we are using the runtime, right?
yeah. So runtime could be any of them. So if you are trying to use Java based application, or if you're trying to use any of the other applications. So for Java, you need to have a this one, Java runtime environment, right? JRE is required,
Okay.
so you can run the
Yeah,
application
yeah,
like
yeah.
that.
Okay. In past, we don't need the runtime. We will just concentrate on application development, right?
Correct. We'll just concentrate on application development to run it across.
Uh, okay, thanks.
So talking about the SaaS, so as I just gave you one example, Gmail, right? So we're not bothered about how it is built, what does it do in the background. For us, all that matters is I am able to send an email, I'm able to receive an email, I'm able to compose an email, I am able to do a Google Hangouts chat on the left hand side. I can do all the various things which are given as a service, right? Or even best examples could also be the applications in your mobile. It could be a banking application, it could be a game, right? These are all software as a service, because we are least bothered how the banking application is built. I just want to download it from Play Store, and I want to do my job of transferring the funds from one place to another. So that is software as a service. Now trying to put it in a big scale, SaaS is more for the end users, PaaS is more for application developers, IaaS is more for the architects who understand the requirements from end to end. And talking about the examples, for SaaS, as I just told, any of the ERP based applications or email or the applications that we use on App Store or Play Store, all of them are examples of software as a service. Platform as a service, if you see, it's a ready environment, which means if someone is a Java developer and he just wants to go ahead and start writing the code in Java, or if someone is a Python developer, he wants to just go ahead and write a code in Python, so then there's a ready environment which is available. So I'll say that if I'm a .NET developer, so I'll say that by default Windows platform with .NET is available. I just log into the system, start developing my code in .NET language. That is application. As an application developer, I can straight away use the PaaS offerings. I don't have to worry about where the server is, how to configure it. Don't worry about it. Everything is pre-configured. As a developer, I just straight away log in and start writing the code for the applications. And for the network architects who understand the platform end to end, right? So most of the large scale companies will have the architects who will deploy the solutions from end to end, because they want to design their own networking components. Then they want to ensure that they are able to choose which operating system to start with, whether it's a RHEL or Ubuntu or a Windows based, or what kind of software they want to build. So even the softwares also, they'll build customized softwares using the Java developers or the Python developers and other things, right? So IaaS is more for the people who understand the things from end to end and can design it well. So that was difference between IaaS, PaaS, and the SaaS, and with the traditional IT offering, right? So with the traditional IT offering, we just saw one major disadvantage. It takes a lot of time for things to get started. Also, my application developers are wasting time from 3 to 6 months without any work in this case, right? So those are the two upper edges that we get started with the cloud platform. And in this slide, we basically talk about how we are going to get started with the cloud. So if you see on the left hand side, I have my company, which is having its own data center, and I have enterprise A, which is one of my companies in US or one of my companies in India, that is enterprise B, and they are all now connected to the cloud because I'm started my migration work. So some things still exist in my data center, but some more things I'm trying to put it in the cloud. So you can start putting in the cloud like Amazon, AWS, or Azure, which is from Microsoft, or Google Cloud Platform, or maybe the IBM Cloud, or maybe we have many more providers like DigitalOcean, Rackspace, Alibaba, and all of them, right? So there are a lot of vendors available in the market, but as I just said, AWS is still a market leader among all of them, and we'll talk about why it is so in next upcoming slides. So any questions or doubts until here from any one of you? Any queries from any one of you?
Yes, I have one query.
Yeah,
So regarding the clouds which you're talking about, these are like data centers which you explained, right? It's a kind of rack or co-location data center in which we are calling it as a cloud, right? So
correct.
if I talk about public and private, the difference between public and private cloud. So let's take an example. If I'm talking about the public cloud, so public cloud is something in which there are shared VMs or vSpheres are lying over there, and the company who is holding, like AWS is holding that particular data center. They are just making some instances for one customer, making other instances for another customer. So it is like that, or like in private cloud, we have a dedicated servers lying over those racks. I mean, how it works?
Yeah, so public cloud is basically a common space, but yes, you can draw your own private line within that. So you can say that I want these two racks dedicated for me. So you can create your own virtual private cloud within the public cloud itself. So you can draw. So if let's say a public cloud is having 1,000 racks within that data center. So as a company, you can say that I want two racks out of which in which I'll start creating my own servers and everything as such, right? So it will be completely dedicated for you. No one else can use those two racks as such. And as a part of free tier, when we use an account on the AWS to test and work out on it, that will be a shared stack. So all of them, when we create a machine as a part of free tier, if you create one machine, I create one machine, someone else creates one machine, it will be all part of shared stack, because as a part of free tier, we get a shared stack itself. But that doesn't mean that our credentials or something will get compromised if you're using a shared stack. No, during a shared stack also, all you have to do is just ensure that you put the proper security guidelines across whatever you're spinning up. Nothing would happen to it. Or but within data center also, there's no connection between the two machines who can steal the data between themselves. That doesn't happen.
Okay, thanks.
Okay, so the next part that we are going to learn is more about the advantages of the cloud. Now let's try to understand why companies are actually moving to the cloud. What are the major advantages that they actually get across with it, right? So the very first thing is trade capital expense over the variable expense. So if you remember the example that we just spoke about a little while, XYZ company and the ABC company, right? So here in this case, ABC company has to purchase the equipment so that they can start the work. And initially to purchase the equipments also, it's going to take some time, and my developers are sitting doing nothing in this case, right? So we can understand that we have to pay salaries to the developers. We also have to purchase the equipments, which is again a cost. And if my project fails, all these equipments have to be sold back in this particular case. right? So we can understand that it's actually initial cost, which will be like a capital. So I'll have to ensure that my application developers are getting paid every month on month until the project starts, until the purchase equipments are being purchased, and also for purchasing the equipments also I need a cost at initial level, right? So all these things would be a huge one to go with. In a cloud, as I just said, you can start with a very small machine. So if the project gets signed off between ABC and the XYZ company, I can ask my developers to immediately go ahead in the cloud account, spin up a very small virtual machine, develop a prototype, and if my client is happy, I'll start the project at a large scale, right? So I'll have to just waste a little money. It is variable expense. So the very first advantage that talks is about trade capital expense for a variable expense. So I don't require a huge capital to get started on for the cloud. Second is benefits from the massive economies of the scale. Now to understand this particular point, let me give you one small query. So if you go to a market today to purchase a hard disk of 1 TB, how much does it cost? You can put your comments in chat box, or you can open up the mic and talk. How much do you actually pay for purchasing a hard disk of 1 TB from a market? Right, around 5 to 6,000, or maybe around 5,000 minimum, right? That is for a magnetic drive. So I hope you guys understand what is a solid state drives. There are something called as SSD in the markets today. Anyone has idea about SSD?
Those are persistent disk with high IOPS.
Correct. So 1 TB of normal magnetic drives cost you about 5,000, and if you go for 1 TB of SSD drive, it will cost you 4 times of it, which is almost 12 to 16,000. So we can just understand the cost is very high in this case. Now in cloud, what happens to the cost? Why is it so reduced? It is because the companies like AWS, Microsoft, GCP, DigitalOcean, Rackspace, IBM, so all these companies have given a huge contracts to the storage solutions companies like SanDisk, Seagate, Western Digital. So they purchase in bulk the devices, or maybe they have set up their own company itself where they have their manufacturing plant from where they can actually create this storage units. So we can understand that every day on the YouTube, some billions of videos get uploaded, and if each video is at least of size of 100 MB, you can just imagine how much storage they would actually require to store those billions of video, billions or trillions of gigabytes of data, right? So in order to store that, they require a lot of storage space behind the data centers, and to do that they're actually having a huge contract with companies like SanDisk, Seagate, Western Digital, and other places. Now if I go to market just to purchase one hard disk, surely it's going to cost me minimum 5,000. But if I say that I'm going to purchase 1 million units on a weekly basis, then what will be the cost of that? It will surely reduce by 60 to 70%, right? So the any vendor will give me a good discount because I'm trying to purchase 1 million units on a weekly basis, just the set of hard disks, right? So that way what's happening is all these cloud companies are purchasing a lot of devices on a bulk basis, maybe on a weekly basis or maybe on a monthly basis, and the other things. That is where they are getting it at a very cheaper cost. So 1 TB of hard disk which we are purchasing for 5,000, the cloud companies might be getting it at only 1,500 to 2,000 rupees itself. And now since they're offering it as a solution, so they can offer it as a very lower cost. So today to store 1 GB of data on the cloud is just $0.01 per month. That is a lowest cost that you can get on the cloud. That is 1 GB of data for $0.01, that is 1 cent we can talk about. Since the companies are purchasing it at a very massive scale, they are able to offer it at a very lower price for us on the cloud to be stored at. That is the benefit from the massive economies of the scale. Third is about stop guessing about the capacity. So understanding again this example where we have the ABC and the XYZ company, right? So here we don't need to worry about the capacity in the cloud, right? So if you think your company is now doing well, I need to expand my infrastructure from 10 storage machines to 20 storage machines, yes, surely you can do it without any problem on the cloud. But if it was a traditional data center, you will have to first fill a purchase order that will go to your finance team. Your finance team will approve it, and then it goes for procurement from the outside market. And once the procurement is done from the outside market for purchasing, then you require a network administrator who will come and set it up. So this is a huge life cycle that goes behind in the traditional data center to increase the capacity as well. But in the cloud, you don't have to worry about the capacity. So if you say I want to spin up from 10 virtual machines to 20 virtual machines, you can do it on the fly. So within next 10 minutes, you will have 20 virtual machines available for you, right? You only pay for the cost that you're using. So if you think 20 virtual machines are a little higher, then you can say, okay, I'll reduce 5 virtual machines from that. I'll go with 15. This is helping me to suffice my problems. So that way, in the cloud, the good thing is you can actually stop guessing about the capacity. You don't have to worry about it. You can increase or decrease at your own pace, and that is what is the next advantage, that is increased speed and agility, which means within no time you have the complete control of your entire data center, where you can just decide how many virtual machines, how many storage accounts, how many databases you require and you don't require. So if you require, you can spin it up. If you don't require, you remove them as well after your use. So there is increased speed and agility. And the fifth and the foremost important point is stop spending money on maintaining and running the data centers. So if you see in this diagram here, once the ABC company purchases these equipments, it has to set up a data center somewhere, right? Maybe inside the ABC software company or maybe inside the XYZ software company. Now, let's say if your company is only 3 floors. Now, to set up a data center itself, it will take minimum 1 room or at least half of a room somewhere, right? Some space it will take in your building, right? So for that particular space, you require 24/7 electricity. You need to ensure that you have a battery backup because you cannot tend to have servers going down. Also, we understand that all these computers, laptops, servers release a lot of heat. So you require AC as a cooling equipment, and then you require a security guard who is looking onto it 24/7 so that no one can come steal the hard disks or server from your place. Right? So you understand that there's a lot of money which is involved in all of this, from talking to electricity to cooling equipments to security and to also the land space that is being required to set this up. Right? Apart from that, we also understand that today if I purchase a laptop, it might be a brand new, but after 2 or 3 years it might not be the same way, because today I might be getting the i7 or i9 processor, but after 3 years then there may be i15 or i17 processor, which at that point of time my laptop would be an outdated one, right? So surely same happens in the IT industry. So if you see through, all the companies usually have a policy that within 3 to 5 years they try to replace the laptops of their employees, because they understand that the laptops might have got slow because of the outdated technology, right? So same happens with our mobile devices. Today we purchase one mobile device, maximum we'll use it for 2 to 3 years, and we see that Android is progressing from version 3 to 4 to 5, and now it's 9. Version 10 is already in beta phase, and once the version 10 goes live, 11 will come into the beta in the meantime, right? So we understand that technology advancements are happening at so fast that our hardware is unable to cope up with the new software requirements, right? So Snapdragon 630, which was there earlier, will not be able to run Android 10 or Android 11. You surely require a good processor which can support it. So surely we understand that with the technological advancements, there are some limitations with the hardware as well. So over the period of time, we also have to upgrade the servers, right? So again, that is a cost to your company. So 3 years you will use it good, but again after 3 years there is a dead cost, or you have to give them back to some other company or sell them off, and you have to purchase a new product again. So spending money on running and maintaining a data center is really a tough job, with security guard in place, with 24/7 electricity, with backups, with cooling equipments, with security guard, and to also ensure that your servers are renewed every 2 to 3 years, or maybe at least 4 years in worst case, right? So all this is a cost to a company, right? And in the meantime, if you lose a project from a company, all of them is gone. So you also pay for all those things. You lost a project, you gain nothing out of it. So with the cloud computing, you don't have to worry about all these things. So if things are working well, you put it on the cloud. If it doesn't work, your project is gone, you will shut down the entire things in the cloud and you come out of it, right? You never owned any of the equipments from that. right? So that's actually a good benefit we get. And next is go global in minutes. So today, if you want to build a website and want to host it, it's very easy on the cloud. Within 5 minutes from here, if you want to do it, you can immediately go ahead, start an account in the cloud, and within 5 minutes you can make your website go live, which will be something like example.com, and people will be able to immediately see it as well, right? So that's the power of cloud, where you can host things within minutes, and you can say that yes, I'm going to make my e-commerce website go live within the next 15 minutes, right? So it can happen. So with cloud, most of the things are easily possible, and you can go global in minutes. So those are the major advantages of the cloud, where a lot of companies are now drawing an effort to move their existing workloads. Because if you see the point number 5, it's a huge cost to each company. Every 4 years they have to upgrade the machinery, they need a space for which they have to pay rent, they need 24 bars on electricity, they need a backup electricity, they need cooling equipments, they need so many security guards. All of them is wiped out, right? So as a company, you concentrate only on your core business, that is all about building a software and start and delivering it to the end customers, right? So we don't have to worry about all of these things across. So that was about the advantages of the cloud, and now we'll talk about why AWS and how it has grown as one of the best cloud providers over the years together. So we'll look at the history of the AWS in this case first, to understand what happened behind the scene. So if you see here, in 1994, Jeff Bezos, who is the CEO of this company, started it. Now it's Andy Jassy, who is the CEO of the company. Jeff Bezos is on the board of directors. So Jeff Bezos was the one who started this company at the initial phase in 1994, and at that point of time, they used to go door to door in order to deliver the books. So initially, Amazon started only with delivering the books, and even it was not even an online platform. It was just that they used to get some requests over the phone or over the written mails or something, and then they used to go ahead and get it delivered to the end users. And then they came up with the idea, why don't we launch Amazon.com, where people can place a request and then we'll get it delivered. So likewise, it started its first online bookstore in 1995. From period of 95 to 2005, they had a biggest change in the entire IT history, where Amazon was able to make up a very big mark, saying that we are one of the best e-commerce companies in the world with the name Amazon.com, right? So a lot of things went in planning behind from 95 to 2005, which helped Amazon to establish its name. So you see here, by 2005, they had their own publishing house. So the authors can come to Amazon, get their book written and published here, and it can be sold on Amazon itself, right? So if it's your own publishing house, you will give the rights of selling only to Amazon. So this way, Amazon was making a great business. Apart from that, they also started selling some of the electronic equipments, right? Not just the books, but they also started selling the electronic equipments, components, and other things. And then they realized that every year on year, they have something like Black Friday sales, they have Cyber Monday sales, and other things, right? So they realized that during that particular sales period, they are actually getting a lot of advantages, like in terms of heavy number of orders. So on a normal day, if they're getting 10 orders or 100 orders on a day of Black Friday or a Cyber Monday sale or on a Thanksgiving, they are getting almost 10,000 orders. So you can imagine 100 orders and 10,000 orders. So it's already 1,000 times more traffic or 100 times more traffic than a normal day. So during that period, Amazon realized that their existing data centers are not helping them to suffice the need. So they actually went ahead and purchased a lot of equipments, servers, storage spaces, and everything in order to ensure that the Cyber Monday, Black Friday, or the Thanksgiving Day sales go very smooth. So that's when in the 95 to 2005, we saw that Amazon was able to purchase a lot of servers behind the scene, but they were used only for maybe 2 months maximum in the month of November and December. Because if you see, the US is always having the festivals during these periods, that is Thanksgiving, Cyber Monday, Black Friday, Christmas, and the New Year. But in India, we can see that it's having at every month on month. Maybe we'll have Sankranti in January, Shivratri in second month, Holi in the third month, Ugadi in fourth month. Then again in June, July, again we'll have starting with Akshaya Tritiya, and then going on with Ganesha festival, then Diwali and other things. But at US, if you see, they only have few festivals which are limited to November and December or January max, right? And during those periods, they have heavy sales, and for those heavy sales, Amazon has invested heavily in the infrastructure. And then they realized that those servers are not utilized for the 10 months altogether or 9 months altogether. So it was adding a lot of cost to the company. And then internally, a committee decided within the Amazon.com that why don't we sell those servers on a rent basis when they're not used for our purpose. And that's when in 2006 officially Amazon Web Services was launched, only with virtual machines and messaging as a service. So only two services were available initially: storage, not even virtual machines, only the storage and the messaging. So in 2006 initially, when Amazon Web Services was launched, only two services were available: storage and the messaging. And after that, what we see was a history, right? From 2006 until today, Amazon has been a leader because it has evolved so much during the period of time that its services are very mature. When we compare with GCP and the Microsoft, the services are still not as matured as what AWS is able to give. So if you talk about the serverless categories, if you talk about developing a mobile applications, or if you talk about satellite based services, all of these are very much matured in terms of what Amazon is offering today when compared to GCP and Azure. And that is what makes Amazon a clear, efficient leader in the entire market. Because if you want to start with the Amazon cloud, you want to be ensured that whatever product you are going to use, whether it's a virtual machine, whether it's a storage, whether it's a database, it's fully matured, it's very easy to use across, and immediately get started with. So with Azure and GCP, there are some glitches, there are some round and round figures that you go through to get started with, right? But with AWS, it's very simple interface and easy to get started with. And also you get a free tier for up to 1 year on the AWS. Of course, with Azure and GCP also you get it, but with Azure you get it only for 1 month, and after that it becomes a paid account. And with GCP also you get it for 1 year, but GCP doesn't have a lot of services, like Oracle database is not available yet, and you don't have serverless functions very well organized on that. So there are a lot of things which are not available on the Google Cloud, and that is where Amazon makes a lot of path for new companies to set their cloud accounts onto. And we can see that on the top, Amazon is now working as a separate company and AWS is working as a separate company. Of course, the whole entity stands with the name of Amazon, but Amazon.com is an e-commerce company and AWS is basically a software IT company, right? So in 2011, if you see here, Amazon.com moved its entire e-commerce infrastructure to the cloud, and that was one of the most complex changes across, because Amazon.com itself is one of the complex e-commerce website, and today if it was able to move to AWS in 2011, that is when a lot of companies realized that we can also move our production workloads to the AWS cloud. And that is when the cloud bubble burst across in 2011, and we can see through in the last 1 decade, in the last 9 years, how much the cloud has actually evolved, and where every company is today talking about shifting their workloads to cloud. So that was about the history of AWS. So any questions or doubts until here from any one of you? Any queries, any doubts from any one of you? You guys can put it in chat box to let me know if you have any queries, or if you, or else you can also open up your mic to ask me any kind of questions until here. Okay.
Pawan, I just want to ask one thing. So, will this help us to clear the
Can you be a little louder? We cannot
trainings?
hear you.
Yeah,
Can
will
you be
this
little...
training program help us to clear that certification course, Solution Architect?
Yes. Yes, so this course completely helps you to have a clear guideline of what you need to prepare for Solution Architect Associate course. So entire course journey will not only help you to get ready for the industry standards work that will be taking through, but also it will help you to prepare yourself for the Solution Architect Associate course.
Okay.
Okay, so the next thing is trying to compare our core infrastructure with AWS. So some of them who are already from infrastructure background will understand this slide very well. If not, it's also okay. We'll take you through a background here. So for any cloud or any company to get started on the cloud, the basic services that are required are storage, database, servers, networking, and security. These are the 5 basic services that any company would look for. Today, if any company wants to start migrating their workload, they'll first ask, do you have these servers available? Windows server, Linux server, or do you have the databases like Oracle, MS SQL, MySQL, PostgreSQL, right? Or do you have the storage space which is unlimited? So if I want to host something like YouTube on the cloud, is it capable of handling it, right? So those are the some things which we may want to have a question with AWS or any other cloud vendor. So these are the basic services like servers, storage, and the database. On top of it, you want to ensure that your network is completely private. So you would like to have your own networking environment. And on top of it, you will ensure that security is the priority, right? No one should be able to attack your servers, steal the data, or anything as such. So we'll see what are the services in traditional infrastructure and what is the comparison service available in the AWS for that. So from security point of view, we have firewalls that we use in traditional infrastructure. We have access control list, we call it as ACL. We have administrators who are sitting across to see that who's granted access to what services and other things. For similar reasons, on the AWS, we have security groups. Firewalls are otherwise called as security groups in this. ACLs become NACLs, that is network access control list. And then we manage the access of every user within the IAM, that is identity and access management. So within this, we are trying to manage every user, what is the level of access he is going to get across. Next, from the networking point of view, here we see that in a traditional infrastructure, we have something like routers, switches, pipelines, racks, layers, and other things we have to purchase from the outside world. But in this case, you can create a own virtual private cloud, which is called as VPC, right? Virtual private cloud. And to balance the load, so if you have heavy loads from the outside world, people are trying to access your machine, you would like to put across behind the elastic load balancer. We call it as ELB, load balancers. And next is on-premise servers, right? So here we have servers on the on-prem. Here what we are trying to do, we are trying to create an image. So image for Windows is already available, image for Linux is already available, image for Ubuntu, RHEL, SunSolar, everything is available. Just pick up the image, which we call it as AMI, and using that image directly create a virtual machine. Here you have to purchase this rack. Inside each rack, you'll have some servers. You have to connect it with the power using the routers, pipelines, switches, everything, and then you will be able to switch on a server. So it will take a huge time. But here directly with the AMI, create a virtual machine, get started with it. Next, for storage, we have like RDBMS, NAS, that is network attached storage, SAN, DAS, and other things. So on the similar basis, here you have something like EBS, which is an elastic block store, EFS, that is elastic file systems. We have S3, that is simple storage service, and the RDS, that is for databases. So for each service that you look at from the traditional point of view, we also have everything on the AWS. So for any core services that any company looks at getting started on the AWS, they have all those services available. That was from the point of understanding the services on the AWS. I'll just go through one of the simple basics of the AWS. So as we see in the AWS today, we have lots of services. You talk about messaging, database, compute, networking, mobile, payments. You talk about the service, it is actually available within the cloud. So as I just said, it has more than 3,000 plus services and the features, and surely it's hard, not just hard, but it's impossible for any single person to learn all of them, right? So we will restrict ourselves to the job role that we are going to perform, right? So specifically the core services are something where most of the people will work with. Apart from that, as you specialize yourself in the next areas like networking specialist, big data specialist, or maybe the machine learning specialist, so accordingly you can choose your job role at the later part of your career. But initially, to get started with AWS or Azure or GCP, you need to know minimum services, that is in networking, database, storage, servers, and the security. So these are the 5 basics that you need to know about. So how are we going to connect to a cloud? All you require is a mobile device or a laptop and the internet. That's it, and we will be able to connect to a cloud console. So to connect to AWS, all we have to give is just go to aws.amazon.com and it will open up a portal for you. So we have to create a AWS account, which we'll be talking about in our next upcoming class, where we'll show you how to create a free account and how to manage it very well so that you do not get any cost in that free account, at least for 1 year. Right? So this is the web page that opens up, aws.amazon.com. So you can go here and say, I am seeing sign in to the console. You will see some message like create AWS account if you're opening it for the very first time. So these are the different set of services we have available on the AWS. But as I just said, we are going to concentrate more on global infrastructure, networking, compute, storage, database, and the security. So these are the 6 core components: global infrastructure, networking, compute, storage, database, and the storage and identity. I'll take you through the global infrastructure in a little 2 minutes. These are what we are going to learn in the part of our course. Just to take you through an initial setup. When we talk about the global infrastructure, it has something called as regions and availability zones. So what is a region? Region is nothing but a geographic location. So if I say Bangalore, Bangalore is basically a region, right? Similarly, in India, we have at one place that is Mumbai. So Mumbai is a geographic location for AWS and GCP as well, right? So within that region, they have availability zone. Availability zone is nothing but cluster of data centers, which means multiple data centers are available inside the each geographic location. So if you look at this particular slide of world map, there are a lot of circles that you can see across, right? So each circle basically depicts that it is a region, and inside the region you can see the numbers, right? So there's a number 2, number 3, number 4 in some of them, right? So the number basically depicts the number of data centers inside that region. So if you see in Mumbai, recently they have upgraded to 3 data centers. Earlier there were only 2. So now we have 3 data centers starting from last year, somewhere in September or October we started off. So it's been around 6 months now. We have 3 data centers in the Mumbai as well. So if you see at most of the places, wherever you can see an orange circle on the world map, most of them actually have the number 3, right? Which means there are minimum 3 data centers in the each region. There's one in the US North Virginia, which is having 6 data centers. What does that mean? It basically means it looks something like this. So inside a region like a Mumbai, I have 3 data centers, and each data center is actually called as availability zone. And why we call it as an availability zone? Because even if one of them goes down, my data is still available in the another one. It is very simple. If you have a image or a PDF file that you want to store in the Mumbai location, it will automatically create 3 copies of your file, and it will store 1 copy in availability zone A, 1 more copy in availability zone B, and 1 more copy in availability zone C. So if one of the data center goes down, it still doesn't matter. You can still be able to access your data from the availability zone B or C. That is the beauty of why we can go to cloud, right? So it's a highly available architecture, which means if anything happens to one of the data centers, you still have the another one which will help you to serve the data. So within a single region, you have multiple availability zones, which will ensure that your data is highly available all the time. So if you see this example, as I just told you, North Virginia is having 6 availability zones. So this is how the naming convention goes, like US East 1A, 1B, 1C, 1D, 1E, and 1F. And for Asia Pacific, Tokyo, since this is in Asia, it will start with AP, that is Asia Pacific. Northeast, because if you see in the world map, it is on the northeast part of the world map. That's why we call it as AP Northeast 1A, AP Northeast 1B, AP Northeast 1C. For Mumbai, it is AP South 1A, AP South 1B, AP South 1C. So these are the naming conventions. You don't have to remember them. Eventually, over the period of time, when you start working in the cloud, you'll automatically start remembering what is the name of Mumbai region, what is the name of Asia Pacific Tokyo region, or the North Virginia. So you don't have to worry about it, memorizing it. So you'll automatically, over the period of time, when you start working on the cloud and applications, you'll start remembering those. So to talk about, these are the set of companies from the different places who are working on the AWS cloud today. So if you talk about the health-based companies or the cloud-based companies like Splunk, Cloudera, Workday, Atlassian products, everything is hosted on the AWS. Even the Adobe, Apple also is on the AWS cloud, right? So technology based, finance based, education based, media based, like something like HBO, Twitter, or the consumer based like Twitter. All of these are also hosted on the AWS. Specifically, the Netflix is also on the AWS. Hotstar is on the AWS, right? So Sony Live all is on the AWS, right? So the lot of companies like media based and all of them are on the AWS itself, and that makes a huge success for any company and also for an end user to start learning on why AWS cloud as a solution. So with that said, any questions or doubts from the initial perspective of our sessions here? So I would like to make one small thing clear here. So even if you're from some specific background, or even if you are from no specific background, do not worry about how will I learn this cloud. I will be taking you through scratch for each of the components, whether it's a storage, whether it's a database, whether it's a virtual machine, whether it's a Linux. Do not worry about it. We will be talking everything from the scratch. So any person who is very new to the platform, wants to understand it and learn it very well, so we will take you through the part of this journey from the scratch and help them to learn through how the course looks like, what is it all about. So I would request all of you guys to please share your details like email ID and the phone numbers to the on your chat box, so that we can help you further.
Yeah, Pawan, this is Shekhar.
Yeah.
Hello, are you audible?
Yes, please go ahead.
Actually, I'm a Java developer. My company wants to do the certification associate next month, so that is the deadline for me. So I'm new to this one AWS. Could you did a help? This training is help to me.
Yeah, so our training is chalked up for 6 weeks. That is like every week we take 5 hours. So my training will go on for 30 to 35 hours. So looking at the graph line, 5 hours per week, we take it up to 6 to 6.5 weeks. That is the course timeline we go with. So where we talk about each and every service in detail, what is storage, what is database, what is virtual machine, what is Linux, because some of them may be very new, they don't understand what Linux is. Some of them may be very new to database, some may be very new to networking environments, right? So we
Basically, I'm a backend developer, so that's what I'm telling.
yeah.
So whatever services you are teaching in this course, those will be covered to the certification. Concept.
Yeah, so whatever will go through the content as a part of our course, yes, surely it is very much helpful for any of the certifications like AWS Solution Architect Associate, or maybe the AWS Developer. So for developer, we are covering almost 80% of the course content, 20% little more differs here and there.
Okay. These daily morning sessions are 9
Yeah,
o'clock.
hello, Pawan.
Yeah, it's a morning schedule every day from 7 to 8 or 8 to 9 in the morning, depending upon the user's feedback that will be given to Visualpath team. We will have that setup being done.
And by when we will start these classes? I mean, what is the start date?
So mostly, I think since today we had a first session, mostly we are targeting from Monday to get started with. So Monday is the timeline we are looking forward with. So request you all to please share the details of your email ID and phone number to on the chat box, so that it will help us further to plan the schedule, and we should be able to have a quick start on Monday or Tuesday, depending upon the number of people who will help us, who will get started with. Right, so we'll have to plan
Yeah,
accordingly. Yeah. So if you guys have already done,
hello, Pawan.
yeah, please go ahead for your queries, please.
Yeah, actually, I'm into Google Cloud. Okay, I'm mostly working in IaaS. Okay, like creation of VMs, taking at the snapshots. Okay,
Mhm.
and using those snapshots, we will create an DR instances like that. But I don't have any exposure into other services like PaaS or storage services. So actually, to my why I'm learning the AWS means I just want to have a hybrid cloud knowledge, multiple cloud knowledge. So I am in bit confusion whether I need to go up with Azure or AWS. Which one you will suggest? Because I don't know, because already since I am into Google Cloud, I know the basic funda, but I don't have exposure to other services except creation of VMs only. Okay, so if I want to learn some other services and get a good exposure, so I just want to take some. I thought to take some other cloud like Azure or AWS. Which one you suggest in down the line, which would help me to have a multiple cloud knowledge in my resume?
Yeah, surely I think yes, multi-cloud knowledge will be the takeaway for after some years together, not immediately today, but yes, multi-cloud will always be a great skill to have in the period of time. As I just said, I started my multi-cloud career only last 6 months back. Before that, I was working only on AWS, but today my company uses all of them, and I need to be learning all the time to understand what is GCP, what is Azure as well. So to say get started with any one of the cloud would be great. AWS, because it's very simple, sophisticated, and easy to learn through. So once you understand what is a storage, what is a database, what is a virtual machine, then learning other clouds should not be a problem, right? So if you start learning with a cloud which is not that mature, you will not understand that concepts, right? So if you talk about the specifically the networking components, the way the databases are being designed in the AWS, that's awesome when compared to what GCP or Azure is offering. Because as a CTO or a CFO of any company, I would not propose my database solutions on the Azure because they still do not give me any ability to create the database within a VPC. That is within my virtual private cloud, I cannot create the database as a PaaS offering. I have to create as a database which is outside of the VPC. I can just create a VPC endpoint. So surely there are a lot of drawbacks when compared with Azure and GCP. But to get started, I would say AWS would be the awesome place to be with because it's very simple, very easily set up, very sophisticated. All services are very matured, and you can get started very easily as well. But yes, over the period of time, not today, but after 3 or 4 years, yes, multi-cloud will surely be a kind of skill that companies would look for, because some things are good on Google, like Kubernetes. So our company uses Google Cloud only for Kubernetes. And in terms of Azure, it is more for PaaS offerings. So our company uses Azure only for PaaS offerings, and more of the things we do on the AWS itself. But still, we need to interconnect all of these clouds because there's some data flowing from one place to another. That's the reason we need to have that hybrid setup being done across all three clouds. But to get started, AWS will be a good place to go with.
Okay, apart from Kubernetes, what are the PaaS offerings you will use in Azure? Because there is a app engine functionalities there in Google Cloud, right? As a
Yeah,
PaaS
so in the
service.
Google, yes, in the Google we have the app engine, but there is no beat the way Microsoft gives the app service plans, right? So there's no beat to that PaaS offerings. Even Amazon doesn't have a great product like what app service plan Microsoft does give it. So it's a great PaaS offering for the developers to get started on the app service plan. Everything is pre-created, everything is being given to you across to develop any application in Java, or maybe any readily solutions are also available on the app service plans, right? So in PaaS offerings, yes, Microsoft has a great edge with app service plans, which neither the AWS nor the GCP has it.
One more thing in GCP, we have for big data, we have different storages like big table, BigQuery, like that, right? So in AWS, do we have anything like that for storing the big data?
Yes, we do have a lot of things. So big data and other things, we have a lot of analytic tools and other things. So we can surely store across them. So if you go to products here, so there's some specific called analytics. So in analytics, you can see there are multiple services like Athena, Cloud Search, Elastic Search, EMR, Kinesis, Kafka, Redshift. So these are all the tools which you can actually have a setup with. AWS Glue, AWS Lake Formation, Redshift. So these are the ones where we can actually have big data part. Redshift, Glue, Lake Formation, and the EMR. So Hadoop framework. So all of these
Okay.
actually help very well with big data part.
Okay.
So in this course, like I'm from networking background. So if you talk about AWS networking, so you will, I mean, give the demo of the basic understanding of networking, or you will show how to integrate with my on-prem data center to the cloud and how to migrate the applications, I mean, the networking devices from on-prem to cloud. I mean, you will give any live scenario or live demo for that?
Yeah, so we'll do one demo for project. So we will do how to set up the so as a part of networking first. So I'll teach you how to create your own virtual private cloud, how to set it up,
Mhm.
what are the important things from the point of consideration of route tables, subnets, and then gateways. What are those? How do we do a peering and other things? So about connecting from on-prem to cloud, we'll have to see if we will be able to cover it up in this course. So if the time permits, we'll surely do it because that is actually part of professional course. AWS Professional Solution Architect is where we actually learn about setting up the point to site to site VPN connections and other things. But provided the time, we'll surely do that labs as well here. But basic part of networking is what all we cover in terms of creating your own VPC, subnets, route tables, gateways, peering, all of these will be covered, and understanding from security point of view how we are going to set up a firewall, NACL, and other things. So these will be part of our networking we'll be covering up.
We cover do we cover on-prem server migration to AWS cloud,
Yeah,
or at
so in
least
terms
if
of,
not,
yeah, in
yeah.
terms of the migration, I'll be taking you through one database migration of the real time, and second one would be about we'll do a one final project at the end, which will be talking about how to integrate all the services, right? So whatever services we are going to learn, using all those services, we are going to build one application overall that will
Okay,
give you
that
a
I understood, but mainly in interest they are asking the the procedure for performing the migration of on-premises server to in AWS EC2 like that. Okay,
correct.
so that is the
So
main that is a generic question. It happens, in every interview they will ask for migration only.
correct. So for that, what we'll do is, see, as I have been through the AWS journey for almost 4.5 years now, so I can give you a better scope of answer for this. So initially, I started my career as a AWS Solution Architect. I used to work under the Cloud Center of Excellence team to develop the POCs and the solutions, and then I moved in as a DevOps engineer. So entire automation part actually works with the DevOps. So I will give you a quick overview about the DevOps. So DevOps without any cloud knowledge is also a waste one, because DevOps has a lot of tools like Jenkins, Terraform, Puppet, Packer, Ansible, Vault, you name it. There are a lot of tools that comes into the DevOps culture, right? But to learn those tools and implement it, you really need to have a cloud knowledge. So what we will do is at the end of the course, I will give you a quick overview and idea about what are the DevOps tools, what is that next level you need to see from this course that is going to help you further, right? So I'll help you with what are your day-to-day job functionalities, what you should answer in the interview from this part of course, how to go through for the next level. And there are some things that you'll have to work hard, because some things whatever I'm going to teach in this course, I would like you guys to go ahead and automate with the help of CloudFormation scripts. That is where that first part of the DevOps will come into the picture. So I'll give that as a task so that you guys learn what is a cloud formation. I'll give you the basics of cloud formation at the initial level, so you can start going ahead and start developing all the cloud formation modules for whatever we are going to do as a lab, right? So I'll expect that you guys can go ahead and start doing that labs with the help of cloud formation scripts, so that when you go down to attend the interview, you can say that how you were writing the cloud formation scripts to automate the entire model of cloud deployments, right? So that is the expectation from an interviewer, and that is also a task that will be given as assignment for you guys when you enroll in this course.
Is show will can you at least show the demo like how we can migrate if not possible in this.
Sorry, can you repeat the question?
Can you show a kind of demo, like how we will do the migration from on-prem to cloud? Okay, if not possible in real, if in this as a part of lab or course, okay, at least we need a theoretical demo.
Sure.
Okay.
We will be doing a demo of it. Don't worry. So we'll be showing you a database migration demo, how it happens. So same case, application migrations will also happen. So I'll show you the entire picture of the framework. So at the end of the session, that is the extra session, what we'll have is all about understanding where to go next, how to attend interviews, what is that I can put in my resume, what are my job day-to-day activities that I do, and those will be the part of the things that I'll be explaining across in the one of the last sessions of our course. So where to go, what to do, how to do, and what to learn next, or how to map all the things that we have learned in our part of course.
And will you cover CloudFormation as well?
So CloudFormation basics will be covered. So expectation will be whatever we do on the console, you guys take it as an assignment and start doing it. So at any point of time you're stuck with assignment, I am surely there to help you across. So I'll take you to the basics of the CloudFormation, how to build a sample scripts, everything will be given. But end of the day, once we complete any lab, maybe for Route 53, maybe for database, maybe for virtual machine, that will be assignment that you guys have to develop a CloudFormation script and you can submit it back.
Okay. Will you help on that?
Yes.
Okay.
Pawan, are you going to cover all the services, right? Which we are using.
Yes, so most of the basic services that we are using in terms of virtual machines, in terms of database, in terms of storage, in terms of Lambda, in terms of networking, security. So these core services, we are going to cover it
Oh,
up.
okay. Is there any course content like that? Are you going to share?
Yes. So maybe in the next particular session, I'll be sharing you the course content, or if not, you guys can get in touch with Visualpath team as well if you want it, so they can mail you the course content as well. Currently I just changed my laptop. In this laptop I do not have one to showcase you, but you can reach out to Visualpath team surely for the core content to get immediately after this call.
Okay. Thank you.
And Pawan, will you explain some real-time scenarios?
Yes.
Okay. So with the examples, like what are the requirements like that?
Yes.
Okay.
Yeah, you may please drop your email IDs for more details for anything that you're looking for. And in case also, if you want to get in touch with me for any further queries, please get in touch with Visualpath team. They'll help you to connect with me so that we can look further to see through how we can take this forward, right? So earlier we have more connections, we'll be able to get started this course maybe by Monday or Tuesday in the morning batch from 7 to 8 or 8 to 9 depending upon your feasibility. And I hope you guys enjoyed the first part of the preview session on the AWS, which helps you to understand what is cloud computing, what are different models, what are the different categories of cloud offerings, and why AWS to be chosen across, right? So we'll talk further more about these things in more detail while we start the journey to our course. The next class will be more about how to get started with creating a free account, how to manage it very well, and then we'll see through also the course content, what are we going to learn across in the part of different set of services. Any queries, any more doubts before we close or wrap up for the day? Okay, I'll take that as no. And thanks a lot for all of you taking a time on a weekend to attend this session. I wish to see you, most of them, on board on for the sessions, and we'll have a great, awesome journey on the cloud with AWS. Thanks all. Have a great time, great weekend, and we'll meet back again.